assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This question says the nitrogen monoxide reacts with chlorine gas according to this reaction here. And it says a reaction mixture initially contains equal partial pressures of NO and Cl, and at equilibrium the partial pressure of NOCl is 115 torr. Finally, it asks what are the initial partial pressures of NO and Cl2. So we'll need an ice table here. I'm going to write the initial partial pressures of NO and Cl2, the variable y. Of course, it says they're the same, so I'm using the same variable. And we have no NOCl at the beginning. I do our change always in terms of x. So this is minus 2x. This is minus x. And this is plus 2x. Of course, whether or not it's 1 or 2 just depends on what term goes in front of this here. Finally, we can write an expression for the value of equilibrium, the initial minus the change. Here. So now we have expressions for the equilibrium, but we have two variables here. Let's see if we can simplify this a little bit. It tells us that the equilibrium partial pressure of NOCl is 115 torr. I'm going to convert that to atmospheres because equilibrium constants are done in atmospheres. This is equal to 0.1513 atmospheres. That's simply dividing 115 by 760 to get atmospheres. We can divide by 2 to get x equals 0.0757. We can plug this x back into these two expressions just to get everything in terms of y. So y minus 0.1513 and y minus 0.0757. Great. Now we can plug all of this back into the equation for the equilibrium constant. It's the partial pressure of the products, or NOCl, squared because of this 2, divided by the partial pressure of NO, also squared because of this 2, times partial pressure of Cl2. So if we plug everything in, Kp equals 0.27, which equals partial pressure of NOCl tells us is 0.1513 in atmospheres squared. Then we have y minus 0.1513 do that real quick. This is squared times y minus 0.0757. Great. And if you work this out, get your final equation, and solve for y, you would find that y equals 0.5668. And this, of course, is the initial partial pressure of each of these gases, which is the same. But if you remember, we did this in atmospheres. So this is atmospheres. And we can convert that to torr by multiplying by 760. And we would get about 429 torr for the initial partial pressure of NO and Cl2.